Hello friends, so we are back at Ashish Singhal #maths. So we continue from the inverse trigonometric functions where we have left in episode 1. Now before starting with the next questions, we would like to discuss the properties of inverse trigonometric functions. See here, the first property is sine of sine inverse x is equal to x, cos of cos inverse x is equal to x, where x is a quantity. Similarly, it follows for the other trigonometric ratios as well. Second property is sine inverse of sine x is equal to x. Similarly, cos inverse of cos x is equal to x, where x is an angle. Similarly, this follows for the other trigonometric ratios. The third property, sine inverse x can be written as cosec inverse 1 by x. Cosec inverse x can be written as sine inverse 1 by x. Cot inverse x is tan inverse 1 by x wherever x is greater than 0. Now what happens when x is less than 0? When x is less than 0, cot inverse x will be equal to pi plus tan inverse 1 by x. So this condition you must keep in mind. Whenever x is less than 0, this is pi plus tan inverse 1 by x. Now moving ahead to other identities. The fourth identity is, there are two parts in that. Sin inverse of minus x is minus sin inverse x. Tan inverse of minus x is minus tan inverse x. Cosec inverse of minus x is minus cosec inverse x. Please see here, for sin inverse, tan inverse and cosec inverse, the result is minus sin inverse x, minus tan inverse x, minus cosec inverse x. Whereas, whenever you have cos inverse minus x, the result is pi minus cos inverse x. Whenever you have sec inverse minus x, the result is pi minus sec inverse x. For cot inverse minus x, the result is pi minus cot inverse x. You need to write down these identities, learn them so that you are able to solve the questions. Now, the next identity, the fifth one, is sin inverse x plus cos inverse x is always equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2, and cosec inverse x plus sec inverse x is also equal to pi by 2. I give you 1 minute time to note down these identities, then we move on to identity number 6 and identity number 7. So I'll be back in few seconds. You note down this. Now, we are back with the sixth identity. Tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus x into y. Tan inverse x plus y upon 1 minus x into y, provided x into y is less than 1. The second one, tan inverse x minus tan inverse y is tan inverse x minus y upon 1 plus x into y. I repeat, tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus x into y, where x into y is greater than minus 1. Then there is another identity, tan inverse x plus tan inverse y will be equal to pi plus tan inverse x plus y upon 1 minus xy. The difference between these first and the third one is the change in the property, the change in the condition. In the third one, x into y is more than 1 and x and y are positive. Tan inverse x plus tan inverse y is pi plus tan inverse x plus y upon 1 minus xy whenever x into y is more than 1 and x and y, they are both positive or they are more than 0. Now we move on to property number 6. The seventh property is writing 2 tan inverse x into either in terms of sin inverse or in terms of cos inverse or in terms of tan inverse. So we can write this as sin inverse 2x upon 1 plus x square. Sin inverse 2x upon 1 plus x square whenever mod of x is less than or equal to 1. The second one, this can also be written as cos inverse 1 minus x square upon 1 plus x square. Cos inverse 1 minus x square upon 1 plus x square whenever x is greater than or equal to 0. Again, 2 tan inverse x can also be written in terms of tan inverse as tan inverse 2x upon 1 plus x square. Tan inverse 2x upon 1 plus x square where x is greater than minus 1 or less than 1. So these are the 7 important properties based on which we can solve each and every question of the exercise. Now, we start with exercise 2.1 from question number 6 onwards. We have done question number 1 to 5 in our previous episode, and now we are going to take up question number 6 onward in this episode. Students, do revise these identities properly. You have already done them in class 11, the trigonometric identities. So this is just an extension of what you have done in class 11. If you are able to recall those identities, you can easily recall the inverse trigonometric functions identities. Now, we have to start with question number 6 of exercise 2.1. Find the principal value of tan inverse minus 1. Find the principal value of tan inverse minus 1. This will be minus tan inverse 1 and this will be minus pi by 4. I hope you follow. Tan inverse of minus 1 can be written as minus tan inverse 1. We have seen the property. So this is minus pi by 4. Now we move on to question number 7. Sec inverse 2 by root 3. Sec inverse 2 by root 3 can be written as sec inverse sec pi by 6. So the answer is pi by 6, and all these are lying in the principal value which we have seen in the first episode. Question number 8. This is cot inverse root 3. Cot inverse root 3 is cot inverse cot pi by 6. So the answer is pi by 6. Question number 9. Cos inverse minus 1 by root 2. Cos inverse minus 1 by root 2. So this will be written as pi minus cos inverse 1 by root 2. This is pi minus pi by 4, and which gives you 3 pi by 4. 3 pi by 4 lies between 0 to pi. So this is the principal value of this function. Question number 10 is cosec inverse minus root 2. Cosec inverse minus root 2. So in this case, we can take minus common. This will become cosec inverse root 2, and cosec inverse root 2 is pi by 4. So this is minus pi by 4. So here we have seen from question 6 to question 10, these all are 1 mark question each. Now, moving ahead, I give you 30 seconds to note down the answers. Now, moving ahead to question number 11. Question number 11 is tan inverse 1 plus cos inverse minus half plus sin inverse minus half. Tan inverse 1 plus cos inverse minus half plus sin inverse minus half. If you see this, cos inverse x plus sin inverse x is pi by 2. So this is pi by 2. And tan inverse 1 is pi by 4. So pi by 2 plus pi by 4 gives us 3 pi by 4. That's the answer. Question number 12. Cos inverse half plus 2 sin inverse half. Cos inverse half plus 2 sin inverse half. Again, we can do it directly as well. Cos inverse half plus sin inverse half plus sin inverse half. So this is pi by 2 and sin inverse half is pi by 6. This gives you pi by 2, this gives you pi by 6. So pi by 2 plus pi by 6 gives us 4 pi by 6, which is equal to 2 pi by 3. Question number 13. If sin inverse x is equal to y, then what is the value of y? Obviously, y is in between minus pi by 2 to plus pi by 2. We have already seen in the table we have discussed. Question number 14. Tan inverse root 3 minus sec inverse minus 2. We have to find the value of tan inverse root 3 plus sec inverse minus 2. Tan inverse root 3 is, everyone knows, this is 60 degree or pi by 3, and this is sec inverse minus 2 gives us minus 2 pi by 3. So this gives us minus pi by 3. Now friends, this is the end of exercise 2.1. We have seen the properties and we would like to continue and start off with exercise 2.2 right now. So before we start exercise 2.2, there are some tips which I would like to give you. Whenever you have to simplify, any trigonometric function, if it is 1 minus x square or root 1 minus x square, always substitute sin x, sin theta or cos theta to simplify the function. If it is 1 plus x square or root of 1 plus x square, substitute tan theta or cot theta. It will automatically simplify the function. Whenever it is x square minus 1 or root of x square minus 1, then you substitute sec theta or cosec theta. By doing these substitutions, you will see that it is always very simple to simplify the given function. Now, we take up the questions from exercise 2.2. Question number 1. Prove the following. 3 sin inverse x is equal to sin inverse 3x minus 4x cube. When you have to simplify this function, we can start from the RHS and we substitute let x is equal to sin theta. So the RHS becomes sin inverse 3 sin theta minus 4 sin cube theta. And dear friends, you already know that 3 sin theta minus 4 sin cube theta is the identity for sin 3 theta. So this is sin inverse sin 3 theta, which gives us 3 theta. But our assumption was x is equal to sin theta. So what is the value of theta? The value of theta is sin inverse x. So this is 3 sin inverse x, which is equal to the left hand side. And hence we prove that left hand side and right hand sides are equal. Now, moving on to question number 2. Here we have to prove that 3 cos inverse x is equal to cos inverse 4x cube minus 3x. Again friends, in this we can start from the right hand side and we assume let x is equal to cos theta. So when you put x is equal to cos theta, this becomes cos inverse 4 cos cube theta minus 3 cos theta. This is again the identity for cos 3 theta, and this gives us 3 theta. Like in the first question, here the value of theta is cos inverse x, so this becomes 3 cos inverse x. So friends, you have seen that the questions are not very difficult. They can be simplified by doing a right substitution. Now, let's take up question number 3. The question number 3 is to prove that tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse half. So dear friends, we have already seen tan inverse x plus tan inverse y. The identity is tan inverse x plus y upon 1 minus x into y. Tan inverse x plus y upon tan 1 minus x into y. Simplifying it further, taking the LCM, 11 into 24, so this gives us 48 plus 77 upon 11 into 24 divided by, see again, LCM is 11 into 24, so this gives us 48 plus 77 upon 11 into 24 is 100 and we can cancel this with 12 and we get 132. So we get 132 minus 7 upon 11 into 12. So this gives us tan inverse 1 by 2. So this gives us tan inverse 1 by 2. So here you can see again, we have used the identity tan inverse x plus tan inverse y. Tan inverse x plus y upon 1 minus x into y. On simplifying, we get 1 by 2. Now, moving on to question number 4th. Question number 4th is a question of the similar type in which it is 2 tan inverse (1 by 2) plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. Dear friends, we can convert this 2 tan inverse x in terms of tan inverse and then apply the identity, but the students find it easier by splitting this expression and finding out the value. So what they do, they write it as tan inverse half plus tan inverse 1 by 7. They use the identity between tan inverse half plus tan inverse 1 by 7. Applying the identity, we get tan inverse half plus tan inverse x plus y upon 1 minus x into y. So this is again tan inverse half plus tan inverse, we take the LCM 14, so this becomes 9 by 14 upon 14 minus 1 upon 14. Simplifying it further, we get tan inverse half plus tan inverse 9 by 13. Again we need to apply the identity in this function. So we again apply tan inverse a plus b, tan inverse a plus b upon 1 minus half into 9 by 13, and on simplifying this we get tan inverse 31 by 17. Tan inverse 31 by 17. So dear friends, we have done exercise 2.2 till question number 4th. Keep revising the formulas, keep doing them, keep learning them, and you will find that these questions becomes very simple for you. Now in our next episode, we will be taking up the questions from 5 onwards. But keep on liking, sharing and subscribing to our channel, Ashish Singhal #mathematics. I know you can always do and you can make the mathematics very simple.